last section of this course, basically, substitution. I'm sure you remember equations like, let's say, e to 4x minus e to 2x, and let's say, what do I want here? Minus 3 equals 0. You can say, I know how to solve this because I know how to, let's put a 2 so it's factorable. So I know how to factor this. True, you can. You can factor it in the e to 2x minus 2 and e to 2x plus 1 equals 0. But let's say we don't know this. I don't see the factor form. If I don't see the factor form, I will say let y be e to 2x, y, only because this can be presented as, anyone?
Y squared.
Thank you very much. So the equation is basically quadratic in form. So I can change this equation into a quadratic equation, y squared minus y minus 2 equals 0, by using this substitution. Solving it for y, and then going back to solve for x. So I will have y minus 2 and y plus 1, and then I get y equals 2, y equals negative 1. I go back and replace, e to 2x equals 2, e to 2x equals negative 1, which is not possible. And from here I apply natural log, so I have 2x equals natural log 2, or x equals natural log 2 over 2. You could say, I don't need your substitution. I agree. If you see how to solve, how to factor this equation, you don't need the substitution. But substitution is really helpful in many, many situations. How is this connected to what we're trying to do now? I was just trying to give you an example from algebra and a similar situation in which you use the substitution to solve an equation. Now we're going to use a substitution to determine an integral. Okay, so I'm going to share my screen. And let's see how this works. Oops, my screen is right here. Okay. So problems, sorry guys, I have to move you. So problems 9 through 54. You choose. I would like to start with an indefinite integral and then definite integrals. So as you see, these are all indefinite, and at some point in time they should switch to definite. Here they are. Okay? So let's start with anything you like to see from indefinite and see how we use a substitution to make an integral easier to handle and finally evaluate it.
Going to 17.
Let's start with 17. Very good. So let me copy it and then I'll stop sharing. So cosine theta over 1 plus sine theta d theta. Okay, good pick. Okay, so remember there is no integral without d something. So this will not exist without this. What is this? Remember, is the sum from f of x times dx. That's all it means. Okay, so obviously I see cosine and sine and in this problem, and I'm asking myself, okay, what should I do here? What substitution I could use in order to make this integral much easier? Sometimes you may find two different substitutions or more that work. You may even get two different functions, but when you differentiate both sides you will get the same thing, so it's possible. Well, in this case I'm thinking of, there are basically two options. Let y be cosine theta or y be sine theta. how do not write them yet. How do I make a decision which one works? At the beginning, I may not be able to make a decision right away. So let's say I don't know. I don't know which one works. I will know immediately because I'm trying to change this integral into something with dy. And I have to get dy in such a way that dy is in the problem. What does that mean? Okay, so let's try this. Dy will be negative sine theta d theta. Obviously, this is not going to work. I don't have sine theta d theta. So this is definitely not what I want. So that leaves it the other way. Leaves the other possibility, in which I have, I'm going to write it again here, sine theta. So dy equals cosine theta d theta. Here it is. This is my dy. And what is the denominator then? 1 over, how do I replace this? Because I cannot have theta and y in the same integral. Everything has to go, in the sense that everything has to be changed in terms of y. If this piece, cosine theta d theta, is dy, what do I replace this by? Any help?
Would it just be sine theta?
So this integral is in theta. I am moving from theta to y. I can no longer.
So y would just be in the denominator.
I cannot.
Y plus 1.
Very good. It's y plus 1. Very good. Awesome. So sine theta is y. So this is y plus 1. Any questions? Any questions so far? So what have we accomplished? A lot, actually. We changed an integral that had numerator, denominator, different functions into 1 over y plus 1 dy. At this point, I know the answer because 1 over, what function prime is 1 over y plus 1? But since it's not just y, I'd like to go through one more step. So if I had just 1 over y, what will I write? What function prime is 1 over y?
Natural log.
Exactly, natural log of the absolute value of y. So don't jump a step, because this is very important. I will say now, let t be y plus 1. How much is dt? What is the differential of t? T is a function, is y plus 1, it's a function of y. And now I want to determine the differential of t. What will I write? 1 times
dy.
Very good. It's the differential, it's not the derivative, right? So then I go back. Y plus 1 is t, so 1 over t dt. And now I know what this is, as you already told me. The natural log of the absolute value of t, of course, plus a constant c. I must trace back. What was t equal to? Y plus 1. So natural log of y plus 1 plus a constant c. What was y equal to? Sine theta. So natural log of sine theta plus 1 plus a constant c. This integral required 2 substitutions. Yes, you could have said, well, but it's t plus 1. It's pretty much the same with you know, y. Is y plus 1 is the same thing with really y. But don't jump steps, because if this is a 2 in here, then there is a totally different story. Okay, so that was a warm-up. Let's choose. We have plenty of time to choose whatever you want.
You said that was a definitive integral, right?
Indefinite. It does not have limits of integration. The definite one is the closed one, if you want. Definite. It has limits of integration. This is the indefinite. So for now, let's work on indefinite.
And when it's closed, it's the right angle brackets. It's not parentheses, right?
Yes, it's between A and B, including A and B, yes.
Is there any variant that uses the regular parentheses?
It's a very good question. See, the integral, very good question. So let me switch for a second so you can see me. The area at the endpoints is 0 anyway, right? So if you include the endpoints or you don't include the endpoints, it doesn't make any difference. Because as we know, the integral from 1 to 1 is 0 anyway. So if you use the brackets or parentheses, as long as the function is continuous everywhere, it doesn't make any difference. Because at any particular point, if you want the area from 5 to 5, that's 0. The area from 3 to 3, that's 0. Does that answer your question, Mark?
I think it does.
Okay, let me know. Okay, back. Okay, so we look at 17. Okay, my turn to choose. 22. And then you're next. Sine 1 over x divided by x squared dx. And I'm going to show a different path, slightly different path. You choose the one you like. And if you have a third one, I'm fine with it too. So I'm looking at this integral, and I realize that there is a function, which is 1 over x, which is inside of another function. So I really don't like that. It's a function composition, right? The sign of a function. So I'm going to say, we'll see if that works. You can use any letter, but you cannot use x. I'm going to say, let u be 1 over x. Now, the important part is to be able to find du. And if du is in the problem, I'm fine. If I need to make minor adjustments number-wise, that's okay too. So can anyone give us du? I'm not asking for the derivative, I'm asking for the differential of u. Anyone, please?
ln dx.
Careful. I know it's confusing.
ln of x.
I know it's confusing. I know it's confusing. Now we're differentiating, not integrating.
So, is that 1 over x squared?
But remember with negative.
Negative.
Yes, and what else?
The dy?
But this is in x. I cannot have x dy.
Dx.
Very good, awesome. So now I'm asking myself, do I have this in the problem? Of course I do. It just needs a minor change, multiplying by -1 twice. And now all this is du. All this is sine u. So I have negative in front. Can anyone tell us what to write next?
Negative sine u over.
There is no over, right? -1 over x squared dx. -1 over x squared dx. That is du. And this is sine u. The negative is included. The negative is included. The 1 over x squared is included, and dx is included. That's why I crossed them out. Everything here is replaced by du. The numerator is sine u. Now, here's a different possibility. If you don't want to do that, which I think is the easiest, but it doesn't matter, solve this equation for dx. So that's what I wanted to show you. Dx equals negative x squared du. And replace it as negative x squared du. You will simplify, you will get the same thing. Whichever you prefer. It's up to you. Because the difference will only be a constant at all times, I do not prefer solving for dx and then plugging it back in. You cannot have x and u together in the same integral. So that's why I'm trying to avoid that possibility. So you cannot, unless you take it on the side and you write this, I have sine 1 over x squared. I'm replacing dx by negative x squared du. I will simplify. I have a negative in front. I have sine u and I have du. But you cannot put all this in the integral. Because here you see you have x and u in the same expression. We cannot have that. Is that clear?